Today, the word MacGyver is both a noun and a verb. Oxford Dictionary site Lexico defines the verb MacGyver as to make or repair an object in an improvised or inventive way, making use of whatever items are at hand. Welcome to WWMD, What Would MacGyver Do? Quarantine Edition. But to know what MacGyver would do, first you would have to do some of the things MacGyver has done.
Our epic journey begins here, at CERN. It's the European Organization for Nuclear Research located outside Geneva, Switzerland. It's difficult to appreciate the scale and scope of this massive complex because many of its record-breaking experiments and detectors are located underground, some 100 meters. That's equivalent to 328 feet. But it's home to two of the world's largest detectors, ATLAS and CMS. And of course, it's home to the world's largest physics experiment, the Large Hadron Collider, which is approximately 17 miles in circumference. And after driving for some time, with the Large Hadron Collider 100 meters below our vehicle, I was stunned to learn the following. The Large Hadron Collider is so massive in scale that a full moon deforms its beam. The orbits of protons in the 17-mile Large Hadron Collider have to be adjusted at regular intervals to account for the gravitational effects of the moon. We were invited to CERN because our homeschooling program with our son, who was 7 at the time, included comprehensive lessons in particle physics and quantum mechanics. Inspired by our methods and our approach and by his advancements, he was named an ambassador. A hydrogen atom has one proton, one electron, but only the proton is going to make this journey. Thousands of them, the protons, are injected in 4 separate accelerators, each more powerful than the previous, until they reach the LHC, where 2 beams of protons are made to orbit in opposite directions, making the 17-mile journey in more than 11,000 times per second, traveling 99% the speed of light. They're made to collide where the detectors, which are essentially cameras, capture the collisions, and scientists and engineers study and interpret these events. But what is hydrogen? Let's get something out of the way. The number of protons in a nucleus defines what an atom is. Hydrogen has only one proton, so hydrogen and a single proton are identical, according to Webster's dictionary. And it has never been observed to decay. And if it does, the minimum estimated time is in excess of 10 to the 34 years. For comparison, some estimate the age of the universe to be 13.8 billion years. Being the most abundant chemical substance in the universe, hydrogen constitutes roughly 75% of all normal mass. Closer to home, the sun is about 73% hydrogen. And of the supposed trillions of atoms in the human body, according to science, 62% is hydrogen. It's in the water you drink. Look at the formula. It's in the food we eat. Carbohydrates. I've designed this 12-part series, What Would MacGyver Do?, to be a place where science is done. I wanted to share with you my journey on how I decided to make hydrogen. And technically speaking, because hydrogen is everywhere, from a chemical perspective, you don't make hydrogen. You liberate it. And of the 3 methods I know of liberating hydrogen in the quantity I need for the research I'm about to do, only the chemical process is suitable. The thermochemical solution is an industrial method and outside my scope for now. Electrolysis is fine, but the yield is low. I'm after a mini Hindenburg. This is my hydrogen farm. We need 3 substances: trisodium phosphate, aluminum, and water. Let's start with aluminum. It's element number 13, and I'm going to need a lot of it. Right here, it's about 25 feet. And here's a fun fact. Aluminum was once thought to be so precious that it was fashioned into a pyramid and put atop the Washington Monument. It's still there today. This reaction will take place faster if I can increase the surface area. We're getting closer to your freedom, your liberation. We combine the aluminum with the water, put in a specific amount of trisodium phosphate. We put a capture device on the bottle. And we let the universe take its course. Over the past 3 weeks, I've conducted about 60 experiments to find the optimal yield. I've tested the water, tap versus distilled versus different brands. I've tested aluminum, thin versus regular versus heavy duty, different concentrations of trisodium phosphate, all to arrive at this moment. Here's what we know of hydrogen. It's colorless, odorless, tasteless, non-toxic, but I want my mini Hindenburg. So it has to be lighter than atmospheric air. Hydrogen is said to have 8% more lifting capacity than helium, which is why it was used in the Hindenburg. I want you to try everything that you've seen me do up until this point. Henceforth, don't try this at home. Alas, we did it. You've been liberated. You are now free. And now, the star of the show. I hope that you've enjoyed discovering more about yourself. See, that's what this journey was all about. My chance to remind you of how wonderful you are, how amazing you are, scientifically, each of us. And hydrogen, The particle that almost defines existence is the particle that CERN accelerates and then collides simply to know the infrastructure of the universe. It's like a carpenter hitting a wall to know where the hidden studs are, to know a house's true infrastructure. And if you were paying attention, you remember the part about gravity? What deforms the 17-mile LHC ring? The moon. Atlas and CMS detectors are essentially what? Cameras. The release of gas and energy are essentially called liberation. Can you name the 3 ingredients I used to liberate hydrogen? Trisodium phosphate, aluminum, and water. Like, subscribe, hit the notification bell. I hope I'll be seeing you soon.